as one of the information provider in today's discussion. Allow us first to introduce our goal objectives. The first one is to apply the concept on how to use the process data and result in reporting learners' performance. The second one is to clearly show the utilization of process data and results in interpreting students' performance outcome. The third one is to enjoy while learning statistics using the tools for analyzing of assessment data. For some educators, the very mention of numbers aim to represent visions of worry. Statistics terrify even those instructors who do not consider themselves mathematically challenged. The emphasis of descriptive statistics, which will be discussed in this chapter, is on describing a set of scores, tables, diagrams, or a single numbers that can all be used to describe anything. And one good example of this is average. The basic idea of statistics is useful statistical treatments that can help with data interpretation and the use of a computer as a tool for data analysis and presentation will be able covered in this chapter. For us to be aware of statistical concept that is necessary in organization, interpretation, analysis, and presentation for evaluation of grades and scores for learners through the aid of computer and for some softwares which are available for statistical computation and treatments. It enables us to collect data, properly conduct accurate analysis, and effectively present the results. Statistics is an important part of how we make scientific discoveries, make data-driven decisions, and make predictions.
Many teachers believe that statistics necessitates mathematical knowledge and time-consuming calculations. The majority of people do not understand the basic statistical principles that are required for organizing, interpreting, analyzing, and presenting grades and scores for evaluation. Computers and certain software are now accessible for statistical computation in addition to calculators. This chapter's statistics are descriptive in nature with a brief introduction to inferential statistics. Also, in this chapter, we'll look at 3 different sorts of statistical measurements. These are measures of central tendency, which identify the location of the center of various distributions using mean, median, and mode. Measures of variations, which can help convey meaningful information about sets of data. And measures of relationship, which are statistical measures that we use in the context of univariate populations. And this will be followed by a more detailed explanation by my other teammates. Lastly, this chapter also covers the statistical treatment of individual data that must be interpreted and which are used by teachers in interpreting data from students. Now, I'll give the floor to my other teammates. I'll be right back.
Hi everyone, my name is Trisha Jean Soto, and in this video I will be discussing the statistic, inferential and descriptive statistic and the differences of these both and the statistical tools. So let me define first the statistic. When I say statistic, it is concerned with the organization, analysis, and interpretation of test score and other numerical data.
And in statistic, there are 3 statistical techniques that help teachers. First is to analyze, describe result of measurement obtained in their own classroom. Second is to understand the statistic used in the test manuals and research report. And lastly is to interpret the various types of derived scores used in assessment.
The statistics enables the teacher to analyze some of the causal factors underlying complex and otherwise bewildering or confusing events. It is common knowledge that behavioral outcomes are the result of numerous causal factors. The reason why a particular student performs poorly in a particular subject are varied in meaning. So, with the appropriate statistical methods, we can keep these extraneous variables constant and can observe the cause of pupils' failure in a particular subject. Also, statistical methods enable us to look at information from a small collection of people or items and make inferences about a larger collection of people or items. Procedures for analyzing data, together with the rule of inference, and central topic in the study of statistics. According to Braced and Braced 2012, he defines statistics as the study of how to collect, organize, analyze, and interpret numerical information from data. The next one is descriptive statistic and inferential statistic. When we say descriptive statistic, it is used to describe the characteristic of features of a data set. The term descriptive statistic can be used to describe both individual quantitative observations, also known as summary statistics, as well as the overall process of obtaining insight from this data. We can use descriptive statistic to describe both interpopulation or individual sample. The various data analysis techniques provide meaningful description of score with a small number of numerical indices. Such indices are calculated using sample drawn from a population and are called statistics. On the other hand, when indices are calculated using the interpopulation, it is called parameters.
This type of statistic is used for summarizing and describing data sets.
However, inferential statistics are powerful tools for making inference that rely on frequencies and probabilities. When there is a need to make a decision, estimate prediction, or generalize about a population based on a sample, then inferential statistics will be utilized. There are two types of tests in inferential statistics. First is parametric. In parametric test, a test of significance is used if the data represent an interval or ratio scales of measurement and other assumptions have been met. The second one is non-parametric. Non-parametric test is used when data represent an ordinal or nominal scale when a parametric assumption have been greatly violated or when the nature of distribution is not known. In simple words, the parametric tests rely on statistical distribution in data, whereas non-parametric do not depend on any distribution. So, inferential statistics focus on making generalization about a larger population based on a representative sample of that population, because inferential statistics focuses on making prediction rather than stating facts. Its results are usually in the form of a probability. Again, to understand the differences between the two is when we say descriptive statistics, it focuses on summarizing the key features of a data set. Meanwhile, inferential statistics focuses on making prediction rather than stating facts. The last one is statistical tools. Statistical tools is to carry out meaningful comparison among sets of test scores. A statistical tools is needed. Measures of central tendency and measures of variability are the most commonly used in statistical tools. The most well-known statistical tools are the mean, median, and mode, range, dispersion, standard deviation, and etc. And that's all. I will not discuss this anymore because it will be reported by the next reporter. I hope you learned something and God bless. Thank you.
Tendency is a central or typical value for a probability distribution in statistics. Averages are a common term for measures of central tendency. The term central tendency dates from the late 1920s. The most common measure of central tendency are the arithmetic mean, or the simply called mean, the median, and the mode. Central tendency is defined as statistical measures that identifies a single value as representative of an entire distribution. It aims to provide an accurate description of the entire data. It is the single value that is most typical representative of the collected data. Why a central tendency is important? In psychology, central tendency is quite useful. It tells us how normal or average a collection of data is. It also reduces the data to a single representative value, which is useful when dealing with enormous amount of information. Central tendency also allows us to compare one data set to another. For the example, let's say you have a sample of girls and a sample of boys, and you are interested in comparing their heights. By calculating average height for each samples, you could easily draw comparison between the girls and boys. Central tendency is also useful when you want to compare one piece of data to the entire data set. There are three main measures of central tendency: the mode, the median, and the mean. Each of these measures describe a different indication of the typical or central value in the distribution. Everyone might know already what is mean. Mean is an essential concept in mathematics and statistics. The mean is the average of the most common value in a collection of numbers, and characteristics are: mean is the most frequently used index of distribution central tendency. It is simply an arithmetic average of all the scores in the distribution. Since it is computed using every score in the distribution, it is an extremely representative measure. If your score is higher than average, rest assured that your score is in a safe zone. But if the highest score failed to pass the exam, probably all students who take the exam might require to take remedial class. Each strength is also its weakness, because several atypically high or atypically low scores, sometimes called liars, can do this or misinterpret the value of the mean. The second one that I am going to discuss is the median, the middle number, found by ordering all data points and picking out the one in the middle. Or if there are two middle numbers, for instances, you need to take the mean of those two numbers. Example, the median of 4, 1, and 7 is 4 because when the numbers are put in order, 1, 4, 7, the number 4 is in the middle. Characteristics are the second most frequently used index of central tendency. It is the point that divides the scores into two equal halves. One advantage of median as a measure of central tendency is that it is not unduly affected, especially by large or small scores. Unlike the mean, the median treats each of these wild scores as a merely another score, no more, no less than other scores. As the mean, the median's strength is also its weakness. The median fails to reflect the magnitude of impact of every score in the distribution, even when a certain of those scores are very high or very low. Last one is the mode. The mode is value that appears most often in a set of data values. It is the most commonly observed value in a set of data. The mode is the numbers that appears in the most. To find the mode, order the numbers from lowest to highest and see which numbers appears the most often. Example, 3, 3, 6, 8, 10 equals 3. The mode is 3. Characteristics are, it is the most frequently occurring score in the distribution. With the most reasonably large set of scores, that mode will occur somewhere near the middle of the distribution, so it can also serve as an index of distribution central tendency. In some cases, a distribution has 2 or even 3 most frequently occurring scores. In such cases, a statistician refers to it as bimodal or trimodal distribution. Multimodal distribution refers to those with 3 or more frequently occurring scores. Since the mode takes into account even fewer data than the median and fewer than the mean, it is not used often in describing a distribution's central tendency. For further understanding, I prefer to encourage everyone to search in Google if you have a spare time. This helps a lot, particularly in doing qualitative research and finding accurate information based on the data that has been accumulated.
Hello everyone, Ms. Davila Mary Rose is once again in your screens. At this juncture, I will discuss about measures of variability and standard scores along with their subtypes. Without further ado, let us deep dive into statistics. Aside from describing how a set of scores tends to the center of distribution, the information about how variables the score are is also important. It is also relevant to know how spread out the scores is, and that is what we are going to talk about in this kind of measurement. Now, measures of variability are the range, quartile, deviation, and standard deviation. The range is most easily computed measurement of distribution variability. It is likewise determined by subtracting the lowest score from the greatest score, and the range's computation is only redeeming virtue since it only involves two values. If a score is excessively high or low, the resultant range will give a false impression of the distribution's overall variability. Now, in the quartile deviation, it is based on the range of the middle 50% of the scores instead of the range of the entire set. It is also known as semi-interquartile range, where quartiles are points on the scale like averages and percentiles, while the quartile deviation is a distance on the scale. It shows the distance between the median and the middle 50% of the scores. Finally, when computing the mean, the standard deviation provides a way of thinking about the average variability of a set of scores. It tells the average distance from the mean for each of the score. The smaller the standard deviation, the more useful the measure of variability. And because it considers the amount that each score deviates from the mean, it is a more stable measure of variability than the others. In conclusion, the quartile deviation is appropriate for assessing small numbers of scores when used with the median. These statistics are derived by counting and are thus unaffected by the value of each score. They are particularly useful when one or more values in the set differ significantly from the others. The standard deviation, on the other hand, is used with the mean. It is a very accurate measure of variability that is particularly valuable in testing. It may also be used to describe a collection of scores, and it can be used to compute standard scores, measurement error, and other statistics needed in evaluating and interpreting scores of students. Aside from the measures of central tendency and the measures of variability, another group of standard scores that may be used in assessment are Z-score, T-score, stanines, and percentile rank. Now, if you do not have an idea what are these things are, in this discussion, we will able to know that. The simplest of the standard scores, the Z-score. It communicates test performance simply and directly as the number of standard deviation units a raw score is above or below the mean. And the Z-score is always negative when the raw score is less than the mean. As a result, it's rarely utilized directly in test norms. Instead of being turned into a standard scoring system that solely employs positive values. T-score refers to any collection of normally distributed standard scores with a mean of 50 and a standard deviation of 10. It is calculated by multiplying the z-score by 10 and adding the result to 50. This formula is true only when the distribution of raw scores is normal and t-scores are preferred over z-scores for reporting test results since they yield only positive integers. The stanines are a type of standard score. These are simply normalized standard scores that demonstrate the normalization procedure. They are single-digit scores ranging from 1 to 9, and they are named as such because the raw score distribution is split into 9 sections with a stanine 5 serving as the distribution center and include all cases within 1/4 of a standard deviation on either side of the mean. Stanines also have key advantages. They employ a 9-point scale with 9 being the highest, 1 being the lowest, and 5 being the average, and they are normalized standard scores that allow students to compare their performance on other examinations. Because it is computed as percentile rankings but stated in the conventional score form and Stanine utilizes a single-digit score, it is easier to record and takes up less space than others. It is one of the most extensively used and simply understood techniques of summarizing assessment results since it reveals a student's relative position in a group in terms of the proportions of pupils who scored lower. In summary, standard scores indicate a student's place in a group in terms of standard deviation units above or below the mean. The different standard scores scales and the percentile scale are interconnected in normally distributed collection of scores, making it feasible to convert from one to the other. Students and the parents find the standard scores difficult to comprehend. Another drawback is that unless the scores are uniformly dispersed, interpretation is very difficult. Now that is all for my report. Thank you so much for your time.
Good day, everyone. My report is all about the indicators of relationship. These are techniques of describing the relationship of the scores in different subject areas. These are graphic presentation. Second, the product moment correlation coefficient. And the third one is the rank order correlation coefficient. So when we say about graphic presentation, it is by using graphic display techniques, the relationship between two variables can be described according to its magnitude, whether it is a strong or weak, and its direction, whether positive or negative. This technique, though, shows that it is difficult to get a firm grasp on graphically displayed relationship because of the impression of visually derived estimates. And the help of this graphic information by using it, it represents a highly developed body of techniques for elucidating, interpreting, and analyzing numerical facts by means of points, lines, arrows, and other geometric forms and symbols. Apart from diagrams, graphic presentation is another way of the presentation of data and information. Usually, graphs are used to present time series and frequently distributions. Graphic presentation represents a highly body of techniques. So the second indicator, which is the product moment correlation coefficient, this is the most widely used indicator or the magnitude and direction of the relationship between two variables. The product moment correlation coefficient, popularly known as Pearson correlation coefficient, named after the English statistician Carl Pearson. This product moment correlation coefficient ranges from 1 to positive 1 to negative 1. An R of positive 1 represents a perfect positive relationship, while a value of negative 1 represents a perfect negative relationship. An R of 0 indicates that there is no linear relationship that exists between two variables. The correlation approach is used with linear related data, meaning data whose scatter plot shows a less straight line relationship. So the Pearson correlation coefficient is very helpful statistical formula that measures the strength between variables and relationship. And when conducting a statistical test between two variables, it is a very good idea to conduct a Pearson correlation coefficient value to determine just how strong that relationship is between those two variables. In statistics, for example, let's say you were analyzing the relationship between your participants' age and reported level of income. You're curious as to if there is a positive or negative relationship between someone's age and their income level. After conducting the test, your Pearson correlation coefficient value is positive 0.20. Therefore, you would have a slightly positive correlation between the two variables. So the strength of the relationship is also positive and considered strong. You can confidently conclude there is strong relationship and positive correlation between the two variables. So the strength of the relationship is also positive and considered strong. You can confidently conclude there is a strong relationship and positive correlation between one's age and their income. In other words, as people grow older, their income tends to increase as well. So the third one, or the last is the rank order correlation coefficient. It is another technique for estimating the magnitude and direction of the relationship between the two variables. This technique was introduced by Sir Charles Spearman. Spearman's correlation coefficient, or RS, is interpreted in essentially the same way as Pearson's product moment, or letter R. So it means they have similarities but simpler to compute. But this one is simpler to compute. Aside from its computational simplicity, it may be used with data that represents only an ordinal scale and not necessarily an interval. So to understand the Spearman rank correlation, it is very important to understand monotonic function. A monotonic function is one that either never increases or never decreases as its independent variable changes. Thus, Spearman's rank order correlation is the non-parametric version of the Pearson product moment correlation. Spearman's correlation coefficient, also signified by RS, measures the strength and direction of association between two rank variables.
Good afternoon, everyone. Good afternoon, ma'am. This is Chisa Bakilyer, and I will be discussing about aid in statistical computing and data presentation, the continuation of report from the Group 9. The essential ideas of statistics and statistical tools utilized for various statistical methods were discussed in the preceding portion of this chapter. But first, what is statistics? And I know most of us have already encountered this word statistics way back in senior high school. But today, let me define first what is statistics. Statistics, by its definition, it is a collection of techniques that can be used to solve key data queries. In the subject of applied machine learning, statistics is often regarded a prerequisite. In addition, statistics is a set of methods for summarizing data and characterizing aspects of a domain given a sample of observations that have been created over hundreds of years. So that is statistics. In relation to this topic, there are simple statistical treatment computations will be explained in the following paragraphs, with an emphasis on the usage of computers in the program Microsoft Excel, and I know we are all familiar with this app or thing. It is a Microsoft program designed to make computations more efficient and error-free. Now, we will know the basic steps to opening the Microsoft Excel program, and I will be showing it to you on my screen. Number 1, double-click on the Microsoft Excel icon, or if it is not available, simply click the Start button to select all the programs. And then double-click on Microsoft Excel to open the program. And this is the first window that will appear, and if you're using the most recent version of Microsoft Excel, simply select the blocked document. And if you're working on a previously created file, just simply double-click to open additional worksheets. Number 2, once you have opened a worksheet, you may start entering data. The scores, which is data that will be processed, can now be encoded. So we will start encoding our data, and that is we start our discussion with charts and frequency distribution. And now, what is charts and frequency distribution? A chart, we will define first what is chart. Chart is a diagram, picture, or a graph that is used to help us understand the information. In statistics, the frequency of distribution is a graph or data set that is organized to show the frequency of occurrence of each possible outcome of a repeatable event observed many times. Simple examples are test scores listed by percentile. For example, the grades of 10 students in mathematics and English are shown in the table below, and I will be showing it to you. So the first column contains the student's class number, the second column contains the student's math grade, and the third column contains the student's English grade. Next, the encoded data can be converted into charts or diagrams. A scatter diagram was created by inserting a tab and then selecting Insert Scatter from the chart options. And Take note that the user can choose different types of charts based on how they want to present their data, such as bar graphs, pie charts, and line graphs are just a few of the charts that could be used. And now we're done with that topic. And now let us proceed to the computing for the measure of central tendency, variability, and correlation. So what are those computing for the measure of central tendency, variability, and correlation? But before I go through with this computation, let me first define what to measure, or what is the measure of central tendency, variability, and correlation is. According from the research, a measure of central tendency, also known as a central location measure, is a summary measure that aims to characterize an entire collection of data with a single number that represents the middle or center of its distribution. A measure of variability is a summary statistic that represents the amount of dispersion in a dataset and how spread out are the values. While a measure of central tendency describes the typical value, measures of variability define how far away the data points tend to fall from the center. Now, for the correlation. Correlation, by its definition, it is a statistical measure that expresses the extent to which two variables are linearly related, meaning they change together at a constant rate. It is a common tool for describing simple relationships without making a statement about cause and effect. And please know that statistical functions are available in Microsoft or MS Excel. Now click the Formulas tab and the different available formulae will be logically organized and displayed. Choose the More Functions icon, then choose Statistical. There are several statistical formulae are provided in the list. For the mean, the function average will be used. For example, for the mean, choose average from the list. Once you click the function's average, the following screen will appear after you click the function average. So that's the end of my report about aid in statistical computing and data presentation. I hope you learned something and how to use a Microsoft Excel. And please know that it is essential for teachers to learn Excel, both as future educators and as current educators. This is because Excel is used to keep attendance, average quarterly grades, create a lesson plan template and schedule, track room inventory, list classroom books, manage summer school rosters, document student behavior, and much more. And in class, students can also monitor with their progress.